All right, problem 3-117. Solve the quadratic below twice. Once by factoring and using the zero product property, and once by completing the square. Verify that the solutions match. All right, so we're solving x squared plus 14x plus 33 equals 0. And real quick, let's just go ahead and talk about what the solution is. If I bring up my TI-84 calculator here, and I'm going to go in and erase the last problem. Let's just go ahead and graph that here real fast. We've got x squared plus 14x plus 33. Okay, and if I take that and I graph it, let's just make sure I'm in the standard zoom window here. Oh, we can't see it on there right now. Okay, so let's go ahead and adjust our window. Need to adjust our x minimum here. We're at -10, but that wasn't wide enough, so let's go -20. See if that's wide enough for us here. Now we can't see all of our parabola, but that's okay. We're just interested right now in our intercepts. And if we look at it here, looks like when we're at -3 here, let's see, when we're at -3 on our x, boom, that's one of our solutions. So one of our solutions we know is going to be -3 because that's where it crosses the x-axis. And let's go ahead and let's just write down our little prediction here. So we got x is going to equal -3. And then let's bring it back up here and what's this other one here? 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like 11 or -11, I'm sorry. So let's plug in -11 there and enter. And that's where our other x-intercept, our root is. So we know that x is going to equal -3 and it's going to equal -11. Let's see how we get that answer factoring and by completing the square. So we're going to start out here using the factoring and the zero product property. And I'm going to go ahead and factor using generic rectangle in case there's anybody here who can't remember how to do it and they feel kind of hung up because they're not sure how to solve it otherwise there, how to factor. So remember, if you want to use the generic rectangle, we first draw our generic rectangle. And we do like our diamond problem here. Some people just like to call it the big X here. So remember our first term, our A term here goes down in the bottom left corner. So we've got x squared. Our C term, 33, goes in the top right. The product of these two, x squared and 33, should go in the top. What about the B term? Well, the B term goes in the bottom. Remember, B term, bottom. We got 14x here. So we need factors of 33x squared that have a sum of 14x. Well, anytime I see a repeated number like that, the first thing that jumps into my head is 11. We're going to have 11x and 3x. 11x times 3x is 33x squared. When you add them, you get 14x. So let's put our 11x here, put our 3x here. Next part, what do 11x and x squared have in common? That's simply an x. X times what gives me x squared? That's going to have to be an x. X times what gives me 11x? That's going to have to be an 11. Same thing over here. X times 3 gives me 3x. And we can double check by 3 times 11 giving us 33. So our equation here on this side, when we factor it, we should end up with x plus 11 times the quantity of x plus 3 equals 0. That's the factoring part. In order to come up with the answers, we have to use the zero product property, and that's the part that a lot of people forget what it is. Remember, this expression times this expression equals 0. So this expression is a factor, and so is this one. If your product is 0, one of your factors has to be 0. So let's take the inside of each and set it equal to 0. X plus 11 equals 0, and x plus 3 equals 0. We solve each of them there. You're going to get x equals negative 11, and x equals negative 3, which is what we got when we looked at our graph, so we know that we are correct. Now remember, you can also write those as ordered pairs. Negative 3, 0, and negative 11, 0. That's how we solve it using factoring and the zero product property. Remember, this is the zero product property part that we're referring to. Now completing the square, okay, well, it does involve some factoring. Remember, we're looking for a perfect square trinomial. Looking for a perfect square trinomial. Right now with 33 here, we don't have one. If we're trying to figure out what our perfect square trinomial would be, just pretend like you were factoring here. And you don't have to do all this stuff out once you get the hang of all of this. You don't have to always draw everything out. But for those of you who don't understand, that's why I make sure I draw it in here, so you have something to fall back on. We know we would have had an x squared here. The number that's throwing us off is the 33. That's not a perfect square. It doesn't work with our 14. We need to take our 14 and we need to split it. Half of it's going to go here and half of it's going to go down here. So half of 14x is 7x and 7x. The rest of it we can figure out just because we have enough information in our generic rectangle. If the area of this is x squared, we know that this side has to be x, this side has to be x. If we're trying to find this side up here, well, x times what gave us 7x? That had to be a 7. Same thing over here. We have the same terms in here, so this has to be a 7. So the area of this missing part here, which is a major part of this, has to be 7 times 7, which is 49. So we need this number to be a 49. Well, what do you have to do to 33 to get 49? We're going to have to add 16. But if we add 16 to this side of the equation, we have to keep it balanced and add 16 to the other side. So let's look at what we have. X squared plus 14x plus 49 is going to equal 16. Remember, the whole reason we did this, we wanted that perfect square trinomial. Now we have it, and now we can factor it. And the great part is we already did factor it. We know the factors are over here. So this factors into x plus 7 squared. That's going to equal 16. Now we just need to solve it. Just like on some of the previous problems in this homework today, we've already solved equations that look like this. We have to get our x out of the grouping symbol, so we're going to have to take the square root of each side of our equation. So remember, that's going to leave us with the absolute value of x plus 7 is going to equal 4. And once again, ask yourself, what numbers have an absolute value that's equal to 4? Well, if we had a 4 in there, that would make that true. Or we could have a negative 4 in there, that would make that true. So x plus 7 has to either equal 4 or x plus 7 has to equal negative 4. Let's go ahead here and solve it the rest of the way. Subtract our 7 and we get x equals -3, and that's a good sign. And we subtract 7 from each side, and we get that x equals -11. So it can equal -3 or -11, which is what we got over here, and is what we got at the beginning when we graphed it. The first method, factoring and using the zero product property. This method over here, completing the square. The first method we did, remember, was graphing it and looking at where it crossed the x-axis. That's 3 different methods that you can use, all to solve the same problem. I hope this helps. If you have questions, please make sure you ask your teacher. I appreciate you taking the time to watch. I hope this helped. Thanks.